Hello, my name is Carla Lauder, and as conference chair, it is my pleasure to welcome you to day 2 of Geo Week. How are we all feeling this morning? You guys ready for some more geographic insights? Yesterday was an exciting day, and it's only going up from here. So far, we've heard from thought leaders addressing the challenges of technology adoption, learned from real-world case studies in our conference sessions, and checked out the latest technologies on the show floor. We even heard from the next generation of geospatial professionals in the academic showcase. Today, I know that many of you are looking forward to this morning's keynote, featuring Jack Dangermond, co-founder and president of Esri. While the term visionary sometimes gets thrown around, there are few people in our industry more deserving of this title than Jack, a true believer in the fact that better maps and a clearer understanding of our world can help to make it a better place. Jack has been a huge part of making that vision a reality. As the co-founder and president of Esri, he has been at the forefront of developing and promoting GIS software and technology for over 4 decades. Dangermond has spoken at numerous conferences and events around the world, and he is here with us at GeoWeek today. He shares his insights on the potential of geospatial technology to drive positive change, particularly in environmental sustainability, public health, and urban planning. I am honored to invite Jack Dangermond to take the GeoWeek stage for today's keynote presentation. Let's give a hand for Jack.
Thank you, Carla. Thank you. Hello. Welcome. Wow, what an amazing audience you are. You know, 40 years ago, I spoke in Denver at an ASPRS and other group conference, and we talked about exactly the same thing that I'm going to talk about today. So there you go. In a way, nothing's changed. Okay, I lost a lot of hair, and don't mention it, please. My wife and I were talking this morning, and I was saying, I really wish I had a joke or something, to start off a meeting. She said, just look in the mirror. That's enough. Anyway, all right, personal inside joke. Listen, it's my great pleasure to welcome you to this very special meeting, and I want to say thanks to the organizers for inviting me. The purpose of this meeting is quite simple, actually. It's being together, sharing, learning from each other, picking up some technology trends, all of these things I put on this slide. It's also about advancing our collective understanding of what we're up to with geospatial technology of various types. And I'd like to also, at the beginning of this meeting, at the beginning of your meeting, really to talk about not just the purpose, but also a couple of words about you. I mean, the purpose is actually all about you and your work, but also you are an interesting group of people. You're probably one of the most diverse geospatial community participants. I mean, you are a diverse community, let me just say it that way. Some of you are from the academy, some of you from private practice, some of you are in the measurement business, some of you in AEC, some of you in mapping of various types. And if you look about here, you'll notice that you're surrounded by people that may not be exactly like you. So I like at the beginning of every one of my talks to have everybody stand up and introduce yourself to somebody new. Could you do that for me right now? Turn the lights on if we can, so that you will start this meeting off properly. Okay, sit down. Thank you. It's just thrilling, actually, when you're with people that are like-minded, a kind of community, purposeful, thinking ahead, and meeting together. So I'll simply return to this notion of the purpose of this meeting is exactly what you're doing, is to meet each other, share, and grow collectively in terms of your activity. Now, why is this so important? Because it turns out that your work is actually addressing virtually all of the big challenges in the world: economic development, agriculture, urbanization and development. And what you have in common is this common approach. I like to call it the geographic approach: measuring, analyzing, visualizing, planning, taking geographic knowledge to action. And at the beginning of this meeting, it's always useful to look at each other's work. So as we get to know each other as a new community, what are you doing collectively? Some of you are working in land use planning, building smart cities, doing urban planning and urban design. Others are looking at climate change and environmental assessment, helping farmers and agricultural organizations. Others still are managing land information, the kind of foundation for our civil society. And increasingly, we're seeing the need for building renewable energy while we go through this massive transformation as a society. These examples show your work in the integration of engineering data with GIS, kind of integration of BIM and CAD into a contextual setting so that we can do better oversight and the whole workflow of design, build, construct, and then manage. Some of you are working in law enforcement and public safety, responding to disasters. Okay, not all of you are doing this, but increasingly we're being challenged by climate change, and it's showing up on our screens increasingly. Location intelligence, economic analytics, and even doing business analytics using your information, imagery, maps, data, to be able to make better and more rational decisions across our entire society. And still others are involved in education, building the next generation of kids that will take your place, a more spatially literate society, looking at demographics, looking at health patterns. This map here in the center, the red one, the John Hopkins map, was looked at about, this is hard to believe, but about 1.6 trillion times. Everybody, like looking at the weather, looked at the disease of COVID spreading across the planet, and it helped people understand what the hell was going on, and then act. One of my best friends, Richard Saul Wurman, often uses the phrase, understanding precedes action. And if there's one thing I want to really emphasize is that you are in the understanding business, whether it's remote sensing or surveying or mapping or the like. You're providing underpinnings which drive so much good that can go on in society. Look, you are looking underground, you're looking above ground, you're doing surveying, you're doing mapping, you're doing imaging, just about every kind of topic that we deal with. Okay, when the people that organized this conference first approached me, I began to think about what should I really talk about that's sort of in your language, because you are quite a sophisticated audience in this respect. And so I dusted off some slides that I've presented before, and I want to present them to you systematically because I want to get everybody on the same page. The work that I do with my colleagues, GIS, information systems, in many ways are mapping common ground. And you are all players in this process. You're creating the foundation for understanding. And it's my belief system that this is a foundation for positive action. And considering the state of world affairs, we need you. You are players in moving the arrows in a different direction. I don't need to spend a lot of time describing that our world is in serious trouble. And humans, because of their footprints and living in some ways carelessly, unsustainably, are fundamentally threatening our future, actually. And I say this quite seriously. This is what I have seen in the way of models from some of the greatest scientists in the world, is that human-induced climate change and the sort of overpopulation of our planet is setting in action so many conflicts that are spiraling out of control. And we see this in the news. I mean, I hardly open the newspapers or look at Apple News today anymore without seeing just going in the wrong direction news. So collectively, I have great expectations of you because I believe that together we can collectively create a future that's more sustainable. As I've contemplated what's going on, there are a couple of central problems. One is the fundamental lack of understanding, those very things that I've been talking about. I mean, normal people, I'm not saying that you're abnormal, but the taxi driver they don't quite understand all of this that's going on. Even I don't understand it. The complexity of our world, the evolution of our world with the human footprint is in many ways not understood. So this lack of understanding, as well as a failure to collaborate, is the fundamental problem that we're facing. And your work, mapping, GIS, they're kind of a fundamental language. They're documenting and telling stories about our world. They help us understand. And also, the framework that we've set up, collectively, all of us, can help us collaborate because it is a common language. You are describing what is and also what could be, particularly what could be is owned by so many in the design profession, in the planning profession. But it's not just in designing and planning, it's all of us. What could we build as a sustainable future? Now, if we look at mapping, it's been around for, some people say 6,000 years or 3,000 years, or I don't really care. But it has always been a technology which is co-evolving with our civilization. You know, there's an advancement in mapping, an advancement in civilization itself. And at this particular time, given what I'm about to show you in the way of advances in tools, it's going to move quicker. Your role is going to be just not documentation, but it's linking science to action. Now, mapping and this thing I'd like to call and introduce you to, called the geographic approach, are powerful means for creating this understanding and exploring alternatives, for finding solutions, for creating a kind of geospatial agreement, mapping common ground, a foundation for positive action. Now, I'm being repetitive here. You can probably tell, say, okay, Jack, I heard you the third time, because I want you to buy into this contextual setting of what you're up to. I like to call this the geographic approach. It's a way of thinking, I'm thinking geographically, and it's a way of problem solving that integrates all kinds of information, that integrates geographic science and empowers that science for human action. It's inclusive. It's science-based. I think of many of you as scientists, but also designers and creators. Today, whether it's from the president or political leaders to academics to researchers, they call on us to take more holistic approaches to problem solving. That's what the geographic approach is about. It's an integrated way. It creates understanding. It's a framework for approaching the future. And my sense is your work will impact virtually every sector of our society. In fact, the examples I just showed are the evidence of this. GIS creates a kind of interesting framework. It borrows from the science of geography, provides a kind of language to do this integration of all factors, environmental factors, economic factors, social factors. It's reflecting the kind of complexity in our world. And it's interesting to pause for a moment to think about the complexity of our world. You know, because of the great work done by the German scientists creating disciplines, we are into ologies, geology, climatology, cartography, And it goes on and on, psychology. They did a great service for us in the 18th century. Well, now we have to put the pieces back together, because while we made great progress in science, this kind of integrated science of bringing things together, we need to do this. And you, particularly you, in your organization of content and the bringing of it together to show patterns and relationships with this concept of a geographic approach is, well, it's interesting to me. Don't you agree? I take that you're getting it, this notion. I sort of live it because, you know, the world is really beautiful. As I get older, I recognize, wow, I miss so much not seeing the little pieces of it, and particularly this holistic vision. GIS is actually interesting because it enables this geographic approach. This thought never really came to me until just a few years ago. I had this same diagram in my mind for 50 years. This idea that it manages and measures data, remotely sensed data, GPS data, etc., in situ data. It allows us to visualize it in mapping, great. It allows us to model and predict things. It allows us to then, my profession, designing on top of that science, and then applying that science all the way down to asset management and construction activities. So GIS is not simply a technology, it's also a process and a framework for applying the very work that you do, geographic knowledge, widely. Well, one might ask, what is a GIS, actually? One of my colleagues said last night, why are you going to talk about this? Everybody knows what a GIS is. Well, is that true? For me, my interpretation is it's a system, like a financial system or a people management system or whatever, for managing and sharing and applying geographic information. And it calls for many different sorts of measurements, field work, the integration of engineering data, the integration of real-time data, and of course maps and data, and increasingly remotely sensed information, integrating it into a kind of living digital twin. Not just a copy like they do in aircrafts or, you know, like that. No, this is a living digital twin that then makes this information, you know, bringing data from distributed services into a virtual environment that makes it accessible for making maps and doing analytics and planning and designing and ultimately engaging the public. I'll come back to that more in a few minutes. This system, I mean, the term a digital twin now is very popular these days, and I like the idea. You know, the digital twin came from the aircraft industry or the car industry, where you made a model and you could test it in various models, looking at wind and so on. But what we are up to as a community is building a living digital twin with models and real-time integration, accessible ultimately everywhere, much like the COVID map reached about 40% of the global population. A kind of living digital twin that is grounded in science, but accessible across organizations, supporting hundreds of different kinds of interconnected workflows, but a constant data model that can be shared and reaches cross-cutting kind of applications in meaningful ways. This kind of system actually encompasses three subparts. For some of you, it's a system of record keeping. I manage the parcels, or I manage my imagery libraries, and I manage the system of record. For others, it's a system of analytics, of interpretation, of creating insights. And for others yet, it's a system of talking to people, communicating through maps or apps that reflect geospatial data. In this sense, GIS is actually all of those systems in one. this technology is advancing, and I suppose that's why some of you came to this conference, is to learn more about what's new, which is always fun at these conferences. What's new is both inside of this GIS cloud, many new advances, hundreds of them really. It keeps evolving. But also it's resting on a whole foundation of evolving science, evolving computing, evolving remotely sensed information, for example, or real-time wiring up the planet. And so for this conference, I thought I would just pick these 8 innovations because they're quite interesting in and of themselves. While there's hundreds of innovations occurring, and if I again look back to 40 years ago when I spoke at this same conference, so much has changed, but conceptually, some of the same fundamental ideas remain. So you can glance through these. You can find your favorite. But actually, all of them together, converging and evolving, is what I really want you to think about. We'll start with this first one. GISs are becoming interconnected. There are literally millions of users that are doing GIS-related projects in forestry, in land management, in real estate, in construction. They're doing suitability analysis. They're doing projects. We call it a project GIS. Others, hundreds of thousands of systems now are emerging. These are systems of record or systems of dissemination of information. And like I say, there's hundreds of thousands of these. It's quite shocking for me. And this third pattern is what I think is emerging. I'm calling it geospatial infrastructure, and it involves the interconnection, like the web itself, actually using web services as a technology to glue things together, the interconnection of services across organizations of all types. This is really about, in a way, fusion, like we used to gather data, put it all in a database, and then we'd have cool applications. But now we have distributed servers all over the place that are measuring the weather, that are measuring geology, cadastral data, facility data, environmental data of various types. And through the magic of web portals, this data is being dynamically brought together and used in various applications. It's quite extraordinary, really. If we look at it holistically or top down, we are wiring up our natural environment with sensors of various types, and also our built environment with rich data models that can bring all of this information together as a living digital twin. This is a different picture that I've painted here, but I just want you to get a sense that we're wiring up the planet and making it accessible. And it's not just wiring it up, it's the ability to use geospatial fusion or geographic fusion or apply the geographic approach to science and various applications. This is interesting because from an engineering perspective, rather than putting all the data, copying all the data, putting it into a single database, today what's changed is I can connect to URLs that have different data formats, hundreds of them, and I can dynamically view the information in a geospatial frame called a map, a web map. And I can overlay those web maps and link together just about any kind of information. Isn't that cool? Okay. You better get excited, more excited. I mean, I don't know. This is really cool. I couldn't have believed that this would happen, actually. That we would take data from every discipline, from every field, and fuse it dynamically as things are happening. This geospatial infrastructure pattern is growing. I'm in a unique position to really watch it, actually. There are literally thousands and thousands of distributed servers that are being accessed by millions of users. They're also sharing data, like over 50 million shared data sets as services. And they're making, as a community, billions of maps every day. The COVID map is one example, but also, well, your work that I shared earlier are all examples of web services-based content being integrated. Okay, this is a bit of an abstraction, but I think of this as kind of a global nervous system. I mean, you guys all know what a nervous system is because you have one. It's about sensing. You as human beings, you sense things, you see things, you hear things, and second, you cognate based on what your observations are, and then you act. So what's emerging on our screen is the evolution of what people have been talking about for years, a kind of open, standards-based environment that allows organizations to use science in various meaningful ways dynamically. A nervous system for the planet. And boy, considering the world is going to hell in many ways, this is what we need. And cognition is part of that. Measurement is many of your businesses, and applications built on top of this are important. Now, right in the center of this diagram is something called portals. These GIS portals are a kind of key way to bring this infrastructure together. They help us organize, like a library would do, and make available these content services. On the right are some really famous national portals here in this country, like the FEMA disaster portal, bringing together American science organizations at the national and state level to respond to national disasters with apps. You can see in the diagram, it's a kind of a portal that accesses this system. And these are dynamic, and the integration is dynamic, just in time. The weather's coming, the train stops, etc. Other ones are emerging like in state and local organizations. Actually, now there are 37 of these at the state level, bringing all the state infrastructure together. And the one that I want to point your attention to is this one called the Climate Mapping Resilience Portal, just done by the White House and NOAA, as well as Department of Interior. It was really calling, based on the president's vision, calling on American science to be brought together to address climate. And so the data is coming in, it's being mashed up, and then with apps that are responsive for state and local governments, it's providing a kind of location infrastructure for knowing where to spend the $1.3 trillion infrastructure funds that are from the bipartisan climate business. Isn't that cool? It's linking science to action. And my view is this is just beginning. Imagery and remote sensing are fueling this kind of revolution. Now, GIS integrates ways to manage large amounts of imagery, to create reality mapping, to do analytics as part of a GIS frame, not a separate stovepipe, but integrated into the main work that people do. And this is not only transforming work, it's also transforming access to imagery, access to science, basically. It's transforming actually all aspects of geospatial work, all of those categories that I talked about earlier, bringing in not just maps or images, rather, but also the applications of imagery, modeling, feature extraction, things like climate change, looking at urban forest changes, all of it. Actually, the examples provide the evidence. Reality mapping, or sometimes people call it reality capture, is extending the power of these engines, GISs. They're creating a foundation for this digital twins applications that I'm talking about. they actually are based on satellites or drone or aircraft imagery brought together to create what I like to call 3D pictures. They're really point clouds, but also survey-grade accuracy inside of GISs, a kind of digital photogrammetry that creates orthomosaics automatically from imagery, that creates orthomosaics or true orthos. This is giving us a new power inside of GIS that we never had before. You know, bringing the communities together with great accuracy, empowering what people do with the GIS. This is an example of one of these reality capture data sets. It's in Vienna. You can look at the point cloud in various ways. It's beautiful, actually. It's a 3D picture. That's a way to explain it. Look at around the UN complex here next to the river. It's extraordinary. I mean, people don't even believe it, because under these buildings can be vector data models that describe all the attributes. Let's move over here to Utrecht in Holland. This is the integration of reality capture with BIM models, just taking a BIM model and dropping it into the GIS frame so I can see various phases of construction within a reality capture 3D picture. I can look at stages of construction. I can look at rooms inside of buildings. Isn't this great? I mean, BIM modeling suddenly become a transaction onto a unified GIS, together with reality capture, together with all of the other information that's here. In other words, we are moving to a stage of GIS where it's 3D, transactionally updated, reality capture driven, humanly accessible by normal people all at once. And part of this is the revolution that's occurring through putting this technology into drone mapping. It's absolutely opening access so everybody can play around with this notion of creating reality captures in small projects, creating these point clouds, deriving dynamically information products that are immediately usable inside of a GIS. This excites me. Drone mapping is a kind of transaction on a big system, but it's also an independent project-based fuel creator for doing real work quickly and cheaply, democratizing it, actually. At the same time, what's evolving is the ability to look at these integrated GISs with immersive technology. This is the integration of GIS databases directly pipelined into game engines, for example, Unreal and Unity. This is revolutionary. We used to have game engine data structures, and then we'd have GIS data structures, and it would cost a fortune to maintain them. This is particularly true in the VisSim environment for the military. Now, this idea of connecting and developing plugins to game engines means that I can have the same GISs viewed in whole new ways, like tabletop virtual reality experiences. This is an example of Gothenburg. It's just a video that's showing how this sort of immersive technology can be derived directly from GIS. This is a GIS data set, but look at the animation stuff that I can do in a game engine, how I can interact with buildings in various ways, visualize them for a whole new community and a whole new audience. I mean, it's pretty cool, actually. That same game engine technology can be used for visualizing interactions between different parts, in this case of a city. I can look at real-time information coming in. And this can support functions like simulating the future with storms, or using the sort of physics model environment and visualization environment to look at the future. Again, all it is a set of clients opened up to access the same digital twin information of a GIS. And okay, some of you are attracted to visualization and making great maps, but for others, you're interested in really modeling and analytics or spatial analytics. Here, there are thousands of tools that GIS people often use, but that's also opening up, and it's also advancing, being able to do more predictive modeling. We saw a lot of that in the spread of COVID, but also being able to do a new kind of spatial analysis using graph databases, graph analytics, entity relationship diagramming, and seeing it as a kind of layer of understanding on top of other GIS layers. Advances in GeoAI and machine learning, not just in imagery, but other worlds and real time. Raster analytics and modeling, particularly in the cloud, are helping us do massive problems. I'll share some of that more in a moment, bring everything together for very large computation work. And speaking about that, again, integration of GIS with and spatial operations with big data is going to give us whole new insights. Let me be more specific. The U.S. Forest Service, and I suspect there's a few of you here, have been using Landsat to create various kinds of forest inventories for years. More recently, they've been putting their large libraries of Landsat into the cloud and using raster analytics to compute things like carbon inventories. This is a big problem. This used to take them months to weeks, got faster. What they're looking for this year is to be able to do these kind of computations in a few minutes. In other words, all of the forests for the entire country updated with new Landsat imagery, providing reports about what's going on in more or less real time or near real time. That's really cool. Some of my colleagues have been working with the Conservation International and the Geo team, and they've been doing the same sort of thing. In other words, massive raster analytics for the entire globe, looking at greenhouse gases and carbon sinks. Now this map looks alarmingly simple. It's the idea of carbon sinks in green and emitters in red. It would be much better if we looked at it in 3D because there's huge spikes. Here it looks like it's kind of okay, it's balanced. But we are living beyond our means with respect to carbon. This kind of geo-accounting template is going to become a kind of standard. Like the UN SDG reporting, we need a accountability with respect to our personal work, our organization's work, our national work, and globally what's going on. And raster analytics at scale are going to fuel this. AI and machine learning, so-called deep learning, is also evolving. It's one of the ones I wanted to hit on. And this is being done in part inside of GIS tools, but also the ability to have open, interoperable technology to integrate the open science that's occurring in this field with GIS as a platform is helping us in remote sensing and imagery. You can see the examples. But it's also helping in being able to extract features from text or do vector geoprocessing to look at patterns and relationships to help us make better decisions. Big data also has been emerging for a couple decades now, these ideas that we can store very large collections in data lakes and data warehouses. What is changing is the ability to send small libraries of software and put it right next to warehouses in a Spark computation environment. This is about putting software next to the data, and whether it's in imagery or whether it's in tabular data or vector data, it's intriguing. This isn't exactly a GIS thing, but it's the libraries right out of GIS, but done so it can scale and create whole new forms of understanding from historical collections. And part of this is real time. Some of you are playing with this, some of you are applying it, looking at everything that moves and changes at scale. And that means integrating IoT, visualizing it, doing analytics both in real time in-stream processing, but also against these large reservoirs of history. And then alerting, you get the idea. It's a real-time digital twin. And in one way, it's not isolated, it's just another layer of intelligence that's inside of integrated GISs. Well, GIS infrastructure is this sort of web services environment that I'm talking about is fueling lots of apps, desktop apps, mobile apps. I mean, I have some users who have 6, 10, 18,000 mobile workers who are being fed by this kind of services environment. And then there's the sort of pervasive web apps like the COVID app. It's just an example. I keep going back to it because it's so very meaningful. But there are literally millions and millions of these web apps that are easily built, low code, no code, that open up dashboards, insights over to data being fused dynamically in real time. I think this is going to empower everyone. In fact, there's a lot of engineering work done to integrate these geospatial infrastructure environments into other IT systems. These are some. So that people working in, for example, Microsoft products can have these real-time services delivered to them directly. People working in Autodesk products can bring geographic context into their engineering design, BIM modeling environment, and so on. Geospatially enabling non-GIS professionals, your colleagues inside of organizations. This is going to extend the reach, actually. And geography thinking will spread. That's my theory. It's more than a theory, actually. Look, at the same time, there are petabytes of data sets becoming available in ready-to-use format that people just connect and bring into their own applications. This shared environment I mentioned earlier has literally tens of millions of data sets and services that are being shared as web maps that are fueling this, what I would call transformation occurring. It's making your data more accessible at local and global levels. And one of the components of all of this has been the absolutely marvelous work done by Amazon and Microsoft and Google and others creating cloud environments that are public clouds or private clouds, also the work of IBM, where software, GIS software, can be put in them and as a result strengthen the capabilities of users doing their work. Also, there's a trend to do more and more SaaS or software as a service application, and these are all becoming more secure. Look, I'll conclude this series of innovations with one last one. That is that GIS, or you might say geospatial infrastructure, as a kind of implementation of GIS, is becoming a platform for open science. And some of you might know that this is the year of science by our nation here in the US. Many academics will understand what open science means. It means somebody does some research and other researchers build on top of the fundamental research that's done by one researcher. This idea of building on that concept where we are each doing our individual work but sharing all kinds of geographic knowledge, our data, our models, our data as services is really enriching. It gives me the chills, actually, because these powerful tools, proprietary tools or open tools for analyzing and visualizing this environment, I think will be meaningful. Also in this environment are people and their backgrounds and organizations and groups, so that this idea of a discovery environment for growing our collective science with evidence, supporting evidence-based decision-making and policy-making is going to be essential, I think. This is, okay, Jack making this up. Actually, it's not just Jack making it up. It's this my belief is that, like the web itself, this will continue to evolve and bring us together to support these significant challenges. So I started saying that the central problem of our time is the lack of understanding. And I wanted to hit on this. You're in the understanding business, like it or not. And also our failure to collaborate. And those big dilemmas are challenging our sustainability. It's not a joke. I mean, we're talking about decades away from big doom and gloom if we don't act rapidly. And this geographic approach, the idea of GIS underpinning it, at least how I make it up, is providing us a kind of practical means for creating agreed upon understanding, for addressing these challenges, linking science to action. Mapping, more specifically mapping, remote sensing, GIS, I think, and would advocate on your behalf, are essential for addressing these challenges. And you can glance through them, take your pick. But also, what's required is the thoughtful work of you mapping a kind of new future, a future that we want to see. So actually, when we talk about GIS, or you want to extrapolate that to geospatial infrastructure, is more than the technology. I was attracted to it when I was a kid. I'm still as enthusiastic about it today. Geospatial professionals have, and this is really all of you in the room, have special and important responsibilities, seeing what's needed and wanted. I mean, you do this, you already do this. And then it's supporting community engagement, connecting data and science to the way that people behave, decision-making, and everything after it. And what I've been advocating is the holistic approaches as we go forward, not only doing in-depth work in your own field, but integrating and collaborating for more holistic approaches are important. And finally, in this age where there's false news and lack of trust with the public, it's your professional, I'd say, responsibility to make sure that we maintain public trust. And that's in those of you who have professional association degrees, it's built into the fundamentals of that. But when we start to work together as organizations, building solutions, building models, it's extremely important that we just keep this as an ethic to link science to action and creating a future that we all want to see. Look, I wrote a few things down here that I want to especially speak to you about. First off, you and what you do matters, actually. No one else actually understands like you do, and or is equipped to provide the kind of solutions that you can, particularly collectively. In this sense, you're privileged, and you're being called upon, or you could say you are calling upon, or I don't care how your philosophy matters here, but you are being definitely called upon at this critical point in human civilization to provide the data and the language and the methods and the infrastructure to help find solutions, find common ground on the planet. And my sense is history will judge all of us based on our success. Good quotation, actually appropriate. In your hands, not in the president's or leader's hands, is the future of our world or your world. He said, your world, and fulfillment of the best qualities of your spirit. So, ladies and gentlemen, thank you very much for coming, and I'll be around. I'll hopefully see you in a few minutes. Thank you.